Hello, I'm Natalie if you don't know me, and I'm a second year foundation degree student on the marine science course, and this is my project. So the title of my project is The Effects of Population Density on Growth Rates and Stressing Lever Sepia officinalis, and these are European cuttlefish, and here you can see my hypotheses for the experiment. So within the package that I've given you, there are many references that I'll be using and utilising for my project write-up, and using it as background research and also as supportive references for my study. The materials and resources that I require include a tank system, including 2 tanks and a shared filtration system, and all water quality testing kits will be required to maintain the system, and also wet weighing equipment and a video camera. So these associated external bodies I've contacted them myself, and they're all relevant to cephalopod research. Not all of them are involved in cuttlefish, but cephalopods in general, it is relevant because they're doing different cultural systems, they're doing different research, and they'll all be interested in the findings I receive. So these are my associated research and recommendations, and I have more within the paper. And I've outlined within my paper why they're relevant to my study, and I've written briefly and used quotations about what is relevant. So for example, Korea, they use the same statistical test that I'll be using, but also others have used the same density of animals and also the same tank systems that I'll be using. So my methodology, I'll be setting up 2 separate tanks, but they'll be on a shared filtration refuge system. So this means that the water chemistry won't vary within the tanks, that removes an extraneous variable. And there will be 10 cuttlefish within one tank and 5 within the other, so high density and a low density. And then they'll be fed twice a day on frozen mysis shrimp, and they'll be fed until citation. So this means that the animals will stop feeding when they want to. It isn't particularly possible to overfeed a cephalopod. And this means that each animal will be receiving the same amount, the amount of nutrition that they require, instead of a set weight amount of food that might not cover all the animals. They'll be weighed by getting a container filled with a set volume of water and weighing out that volume. And then I'll be putting the cuttlefish into the same volume of water and weighing out the differences within that. And I'll be doing it at the beginning and the end of the study. And the duration will be 8 weeks. But I can tailor this to the animal's needs and also to the study. So if it appears there might not be a significant growth rate, I could extend it slightly just to see if there is significant differences over a longer period. Water chemistry will be monitored regularly, and 10% water changes will be conducted every week to maintain the system and ensure the animals are healthy. I'll be using unpaired t-test as my statistical test to analyse the data. And this is because the data is parametric and the 2 groups are independent of each other. Within the package, I've also included an ethical review, and the main issues that are with this study is going to be stress to the animals. Obviously, the higher density, there may be high levels of stress. Human impacts of people entering the lab and disturbing the animals and increasing the amount of their inking, and also the weighing method can cause stress. However, I've taken these into consideration, so if there does seem to be a specific problem, I can alter it. So possibly the high densities are too stressful, I can remove animals and make the density slightly smaller. But my project can be halted at any point for the animal safety. My contingency plan, I also have 5 spare cuttlefish in a separate tank from a separate system, and these are of the same age and are being fed the same amount and the same food type. So if, for some unforeseen circumstances, an animal were to pass away, I can replace them, but also I have alternative experiments as backups in case the study is causing serious problems with the animals, as it's for their safety and health that I'll be altering it. My schedule of operations, I plan to be finished by the 13th of December in my data collection, and during that period I'll be collecting all the results and writing them up, and also writing up my method, and after it's all collected, straight away I'll be doing the unpaired t-test to get my statistical data. I've also included an appendix, and within that I have a risk assessment of the lab environment, as the animals are venomous and could cause issues if there was a bite. I've created results tables for the data that I'll be collecting, and I also have the link to my Weebly site set up. Thank you for your time. Do you have any questions?
If you don't mind, you were saying about ethical reviews. You know, cephalopods have just gone through an interesting change in the legislation associated with ethical reviews. It's meant that you can no longer sample weigh them on a weekly basis. So, could you just sort of remind me, update me, how are you going to measure growth rates or size increases?
Well, at the beginning of the study, I'll be wet weighing them, and then at the end, but I've also tailored an alternative method of measuring them. So on the front of the tank systems, I'll be drawing a grid system, and it will be around about 1 centimetre wide columns. And during the animals' feeding or behaviour, I'll be setting up a video camera and recording their movements, and I'll be trying to get them on a side-on profile to the tank and trying to get a rough estimate of their mantle length, which is sort of behind their head to the end of their body. And this is sort of an accurate measurement of their growth. Obviously, it won't be specific, but it can be approximate, and then I can compare that to my results I find from the wet weighing, and if there does seem to be proportionate growth.
So you can even look at the correlation between body length and weight?
Yeah, as sort of alternative as well.
Brilliant. Great.
In language terms, where would your study fit in within the industry? Where will it take the industry? What would be different about it?
Well, for starters, cephalopods are sort of heavily researched in cultural systems because they're such, well, they have very short lifespan for starters. They only last around about a year to 2 years, even shorter than that. So they grow very quickly. So culture systems at the moment are trying to utilise these animals because they don't need that much space relatively, and also they grow quick. So this data on densities, it can be useful in terms of this density may cause faster growth. So even if they need more room, there could be a faster turnaround rate of the animals. Also aquariums, obviously they have displays and they'll be having young being bred, and they might not have a large amount of room in the back of the aquarium where people don't see. So having sort of these defined limits of this worked and this didn't may be useful to the industry in terms of how they can use the animals without causing stress and harm to them.
Okay, thanks.
In your ethical review, you talk about a light regime, a 12 hours photo period. Can you explain that a little bit further?
Well, the lab where they're going to be, it's not got much natural sunlight, and the issue is walking in and just turning on a light switch will probably spook them and it will cause stress to the animals. So what I've devised is getting some sort of light source on a dimmer and a timer, having that within the lab, and from say 7 in the morning it begins to start up so that the light levels rise gradually in mimicry of the wild. And then also the same in the evening, so people don't just walk in and turn on light, that it's a gradual, natural cycle of light for them.
Any questions?
That's it. Brilliant.
Brilliant. Well done. Brilliant.